Good morning everyone, this is Bonani Paragasto and I am here with the chapter number 3, Matrices. Matrix is the singular form and matrices is the plural form. So if we say matrix, so it represents only one matrix, and if we say matrices, so it means there are more than one matrix. So before going to the definition of the matrix, let us start with some linear equations. So see, I have written here one pair of linear equation with two variables. So all of you know how to find out the values of those variables. In the next one, you see I have written three linear equations with three variables, and the variables are x, y and z. Here also you can find out the values of x, y and z. But see, if we keep on increasing the number of linear equations and the number of variables, it would be very difficult for us to find out the values of those variables. So to simplify that, we use matrices. So a matrix is an ordered rectangular array of numbers or functions. Ordered means what? Ordered means a pattern, already set pattern, and array means arrangement. And it is, we denote a matrix by capital letter and the elements of the matrix are denoted by small letter. So see, here I have written one matrix and it is denoted by capital A, and the elements of the matrix are denoted by small a. So see, here I have written A11, A12, A13. So these all three elements are the elements of row 1, and A11 is the first element of row 1 and column 1. What is column 1? Column 1, you see A11, A21, A31, these are the elements of column 1. The next one you see A21, A22, A23, these are the elements of row 2, second row. And A12, A22, A32, these are the elements of column 2, second column. A31, A32, A33, these are the elements of row 3, and A13, A23, A33, these are the elements of column 3. See, Aij is the element of ith row and jth column. So whenever we say A12, from this we can understand that A12 is the element of the first row, second column. In this way, if we say A23, this will the elements of a second row, third column. And see, here I have written 3 by 3 order of the matrix. So here how many rows are there? There are 3 rows. And how many columns are there? There are 3 columns. So the order of the matrix will be 3 by 3. We write the elements of the matrix inside a third bracket, and this is the symbol of matrix. A matrix having m rows and n columns is called a matrix of order m by n. So m represents what? M represents the number of rows and n represents the number of columns. So here I have written a matrix and it is denoted by capital B. The number of elements are mn. So here we have m rows and n columns, m number of rows and n number of columns. So see, the elements are represented by small a. So see, in first row we have A11, A12, A13 dot dot up to A1n. So A1n is the element of first row, nth column. In the second row we have A21, A22, A23 dot dot up to A2n. A2n is the element of second row, nth column. In this way, the last row is AM1, AM2, AM3 dot dot up to AMN. So AMN is the element of mth row and nth column. Suppose AM1, what is AM1? AM1 is the element of mth row, first column. And the order of the matrix becomes m by n. Number of rows here is m and number of columns here is n. Let us move to the types of matrix. So first one is the column matrix. What is column matrix? Column matrix means if a matrix has only one column, then that matrix is called column matrix. So here I have given some examples. Matrix A, see matrix A. Matrix A has the elements 3, 5 and 9, and all the three elements are in a single column. So it has only one column and how many rows? 3 rows. So the order of the matrix becomes 3 by 1. In the next one I have written 7, 5, 3, 2. Matrix B. Here also we have only one column and how many rows? 4 rows. So the order of the matrix will be 4 by 1. In the next one we have row matrix. In the same way, row matrix means if a matrix has only one row, and then the matrix is called row matrix. So here we have some examples. So I have written the same matrix, that means we have the same elements 3, 5 and 9 for matrix A, but here I have written matrix A like a row matrix. 3, 5 and 9 are the elements of a single row, and we have here 3 columns, and the order of the matrix becomes 1 by 3. So if we compare the matrix A of the column matrix and matrix A of the row matrix, we can understand it better. So in matrix B, the same elements also I have written. Here also we have only one row and the elements are 7, 5, 3, 2. Here the number of column is 4. So the order of the matrix will be 1 by 4. The next one is the square matrix. What is square matrix? Square matrix is that matrix which has the same number of rows and columns. So the number of rows and the number of columns will be equal. So here I have given 3 examples. Matrix A has 3 rows and 3 columns, so order of the matrix becomes 3 by 3. In the second matrix, matrix B, we have 4 rows and 4 columns. So the order is 4 by 4. Matrix C has 2 rows and 2 columns, so order of the matrix becomes 2 by 2. The next one we have diagonal matrix. What is diagonal matrix? Diagonal matrix is that matrix where the non-diagonal elements are 0 and the diagonal elements are not 0. So what are the diagonal elements here? See, in the first example of matrix A, I have marked the non-diagonal elements, and I have the diagonal elements 1, 2 and 3. So one is what element? 1 is the element of first row, first column. 2 is the element of second row, second column, and 3 is the element of third row, third column. So this matrix is of order 3 by 3. In the second example we have the diagonal elements are 1, 2, 3 and 4. So this is the 4 by 4 matrix. So see, these two matrices are square matrices. So to get a diagonal matrix, the matrix should be a square matrix. That means the number of rows and the number of columns should be equal. So we can say a diagonal matrix is also a square matrix, but all square matrices are not diagonal matrix. Next is scalar matrix. What is scalar matrix? Scalar matrix means when the diagonal elements are equal and the non-diagonal elements are 0. So here the first example, matrix A has 1, 1 and 1. These are the diagonal elements and all the diagonal elements are equal and the non-diagonal elements are 0. So this is a 3 by 3 matrix. Matrix B has, and the matrix B is also a scalar matrix and the diagonal elements are 2, 2, 2, 2. Non-diagonal elements are 0. So this is a 4 by 4 matrix. So a scalar matrix is also a diagonal matrix. If scalar matrix are also a diagonal matrix, then it is also a square matrix. So we can say a scalar matrix is a square matrix. The next one is the identity matrix. Identity matrix means the diagonal elements should be 1 and the non-diagonal elements are 0. So here I have given 3 examples. See matrix A. Matrix A is a 2 by 2 matrix. 2 by 2 matrix means 2 rows, 2 columns. Here the diagonal elements are 1, 1 and the non-diagonal elements are 0. In matrix B you see it is a 3 by 3 matrix with what? 3 rows and 3 columns and the diagonal elements are 1, 1 and 1. Same is there in matrix C. The diagonal elements are 1, 1, 1, 1 and the non-diagonal elements are 0. So a identity matrix is also a square matrix. That means in the identity matrix we should have the equal number of rows and columns. The next one is zero matrix. Zero matrix means all the elements are 0. See in matrix A we have two rows and 2 columns and all the elements are 0. In matrix B we have 2 rows 3 columns. So it is a 2 by 3 matrix and all the elements of matrix B are 0. So this is called zero matrix.